السلام عليكم. لا تنسوا الاعجاب بالفيديو والاشتراك في القناة تشجيعا لنا لنستمر بنشر المزيد ان شاء الله.
An air conditioner is a part of a central heating and cooling system. Draws heat energy out of the house and transfer it to the outside air. Most air conditioners starts out as raw material in the form of structural steel shape and sheet steel. From the shear press, the steel metal is loaded on a CNC punch press. That machine cuts the metal sheets into a parts of layer. After these, all parts must be completely clean and free of dirt, oil and grease before they are powder coated. Before brackets, pans and wrappers are assembled together, they are fed through a powder coating operation. The powder coating system spray a paint like dry powder to the parts as they are fed. After these, the condenser and evaporator both act as a heat exchanger in air conditioning system and are made of copper or aluminum tubing bent around in coil form to maximize the distance through which the working fluid travels. A major part of the assembly is the joining of the copper tubing with the aluminum plates. After this designed to increase the system pressure and circulate the working fluid, the pumps is connected with the fitting to the system. Compressors, condenser and connecting tubes are branched by highly skilled branching operators. After confirming in line helium leak test, parts are assembled. After this processing, outdoors units are assembled.
Everything you know is in your mind.
Each and every air conditioner has to pass through performance testing to allow itself into the next stage. Packaging are done by auto strapping machine.
Higher-end cars typically come with alloy wheels rather than basic steel wheels covered with a hubcap. Called mag wheels because when they first came out, they were made of an alloy of magnesium, today's alloy wheels are made of an aluminum alloy, which is far more durable. Aluminum alloy wheels are not only more attractive than standard steel wheels, they're also a fraction of the weight, and therefore require less energy to rotate. This contributes to greater fuel efficiency, as well as better handling, acceleration, and braking. Manufacturing them begins with high-grade aluminum alloy, containing 97% aluminum. A furnace heats the ingots to 750 degrees Celsius. They liquefy in about 25 minutes. The molten aluminum then flows directly to a mixer, in which they inject argon gas, which enables them to remove the hydrogen. This increases the density, making the aluminum less porous when solidified. After adding powdered titanium, magnesium, and other metallic elements to further strengthen the aluminum, they blend in flux, a chemical which draws aluminum oxide to the surface. They skim off this impurity along with the flux, and the liquid aluminum is ready for casting. The wheel mold is made of high-strength steel. It's actually a set of 3 molds: the upper mold, which forms the inside face of the wheel, the 4-part side mold, which forms the wheel's edge, and the lower mold, which forms the outer face. That's the side with the design, so this is the most intricate mold. It takes 3 to 4 weeks to produce a mold. Computer simulations check the flow and temperature of the liquid aluminum, factors critical for preventing casting defects. The casting machine is designed to fill the mold from the bottom by pressurized injection. Injecting upward through the bottom, rather than pouring downward into the top, reduces the risk of air bubbles, which cause defects. Right before casting, the molten metal flows through a filter sheet made of high-temperature resistant ceramic. This traps additional aluminum oxide. Once cast, the aluminum takes about 7 to 10 minutes to solidify. Then the mold automatically opens, releasing the newly cast wheel. Workers submerge it in lukewarm water for a few minutes. This cools it down enough to be handled. The wheel undergoes a complex heat treatment process that takes 12 hours from start to finish. First, they heat the wheel to 500 degrees Celsius. This rearranges the molecular structure, strengthening the metal. Next, what's known as quenching. They submerge the wheel in 80-degree water for 30 seconds. This locks in that new strength. Then they reheat the wheel, this time to 180 degrees for 9 hours, to further stabilize the metal. The wheel doesn't come out of the mold in perfect condition. The edges are rough due to some excess metal that has to be trimmed off. So they mount the wheel on a computer-guided lathe. It precision machines the sides, refining them to within 0.05 millimeters of the measurements specified in the technical drawings. As for the more intricate face of the wheel, a worker manually trims the edges with a blade. The shape now finalized, it's time to test the wheel to make sure it's airtight. While pumping air into the wheel, they submerge it in water. Should any air bubbles appear, it would mean there's a pinhole in the metal or some shrinkage, in which case the wheel would fail inspection. No air bubbles, the wheel proceeds to the automated painting line. First, a base coat, then a coat of color, which can be anything from classic silver or black to a flashier shade. Then a clear coat to protect the paint and prevent corrosion. From every 1,500 or so wheels, the factory randomly selects 2 or 3 to test for performance and wear. Workers install the decorative cap that covers the center hub. It typically bears the specific brand's logo. Then, a final cosmetic inspection to make sure these aluminum alloy wheels look as good as they perform.
A lot happens when an inflated rubber ball hits the ground. The rubber compresses and quickly snaps back to its round shape. That snapping back makes the ball bounce. In addition, the air inside the ball acts as a tightly coiled spring, increasing the rebound. When an inflated rubber ball falls to the ground, it bounces back and players catch it on the rebound. This type of ball is at the heart of many games, from basketball to soccer to volleyball. At the core is an inflated rubber bladder. Making it starts with a sheet of natural rubber. The factory worker folds it in a specific configuration. He places a die on top and activates a press to force it through the layers, which cuts out the shape. He now has the bladder of a sports ball. He brushes an adhesive around the hole in the bladder and inserts a plug. Another worker inflates the rubber bladder as she places it in a spherical chamber. It heats and cures the rubber for 5 minutes at a temperature of 284 degrees Fahrenheit. The rubber bladder spins on a revolving cylinder, causing it to take up nylon threads. The threads twist around the bladder and form a layer that both strengthens it and keeps it round. The material that will form the exterior of the ball is made using colored synthetic rubber, natural rubber, magnesium carbonate, and mineral oil. Once it cures, a worker rolls it into thick sheets and slices it to a specific width. He folds it several times. This blue rubber will be used for volleyballs. The folded rubber now travels between a series of rollers. They flatten it and press it extremely thin, and it becomes both lightweight and formable. An automated blade slices the rubber into shorter pieces. A metal pattern cutter will now be used to cut the rubber into strips, which will fit together to form the outside of the ball. These particular strips are for a basketball. The worker places the pattern on several pieces of rubber. A press forces the sharp-edged pattern through the rubber to cut out fish-shaped strips that are designed to fit around the round bladder. She lines the two halves of a bonding chamber with the strips. She inserts the bladder and reinflates it. She closes the bonding chamber and activates it. Inside, heat and pressure cause the strips to stick to the bladder. To make a medicine ball, which is used for exercising, a different pattern cutter is used. The forming process is the same, but this ball has a unique visual impact, very different from that of the basketball. Back at the basketball station, a worker applies the brand name to the outer skin in 2 places. Glue helps the decal stick to the rubber. This mold will now transfer a pattern onto the rubber ball, while also baking the lettering into it. Another worker places the ball in the mold and pumps more air into the bladder. He closes the lid. The mold applies heat and pressure to emboss the pattern onto the rubber. The lettering has penetrated the rubber, and the worker peels off the decal plastic. Another worker replenishes the air that's been lost to make the ball completely full and round. The ball is now ready to receive its stripes. The worker paints black rubber into grooves that were formed during embossing. This rubber quickly cures to become part of the ball. Another worker inserts a fill valve into the hole. Then mechanical fists squeeze the ball to deflate it. This prepares it for packaging. With the valve inside, it can be easily reinflated by the customer. A worker wraps it in plastic and ships it to the retailer. Making this rubber basketball has only taken a couple of hours, but it should be able to take a lot of knocks and bounce right back.